What's going on, everybody? Mr. Barry here, talking about solving equations, of course. In this case scenario, we have our variables on both sides of the equation, both the left and the right, going ahead and trying to solve the problem. So here, take a look at this problem. 3x minus 2 is equal to 3 times the quantity, x plus 1 minus 5. First thing that stands out to me right from the get-go is the fact that I have a little bit of distribution to do with that parentheses there and the x plus 1 inside of it. So I'm going to take care of that first. Remember, when I distribute, I'm only going to distribute here to the items inside of the parentheses. So there's this minus 5 on the back end. We're just going to let that hang out for a little bit. I distribute 3 times x is 3x, and 3 times 1 is 3. Not terrible right there. Everything else is going to drop down. We have our 3x minus 2 on the left. I have that minus 5 on the right. And remember, what we just did there was the distributive property. I want to make sure we do that first. If it's in a problem, no doubt about it. Now remember, when we have variables on both sides, our goal or one of our goals is to make sure we have variable and a constant on the left and a variable and a constant on the right. Getting it to that spot right there helps us kind of move along in the problem. I have a variable and constant on the left side, but I have some combining like terms to do on the right, specifically with the 3 and the minus 5. So what I want to go ahead and do here is do 3 minus 5, and 3 minus 5 would be negative 2. Combining those two terms right there, 3 minus 5. I didn't move across the equation. I only did information on the right side of the equation there. So take it for face value. 3 minus 5 is negative 2. Left side's going to just drop down again, 3x minus 2. Now at this spot, I know sometimes when we do these problems, we kind of just move along and do them as quickly as possible. But we have 3x minus 2 on the left. We have 3x minus 2 on the right. It's the same exact thing. And even if I try to get the variables all on one side, which I usually do, I just like doing the variables first as opposed to the constants. That's a positive 3x. So if I do the inverse operation and subtract 3x from both sides, 3x minus 3x is 0x, which we know 0 times anything would be 0. So both on the right and on the left, there's going to be no variables left in the problem. So I would be left with a scenario where I have a negative 2 on the left and a negative 2 on the right after using that subtraction property of equality. And I have a scenario, again, where my variables have disappeared. I no longer have any variables in the problem. 3x minus 3x made 0. They went away. So there are no variables left in this problem. You know, we've done plenty of problems where we have a variable left over. And that usually gives us a scenario where we have one answer, one solution to the equation. But here I have no variables left. But we have to go back up to that statement, negative 2 is equal to negative 2, and kind of understand, is that a true or false statement? And negative 2 is, in fact, negative 2. What that means is any number that I could think of, all the real numbers we could potentially have, would be able to be placed up in here for x into the original equation, and we would have the same exact number on the left as we would on the right. Because that's the case, no matter what number we pick, it's going to give us a true statement. We're going to go ahead and answer with the fact that there would be infinite solutions for this equation. Now, sometimes you'll see infinite solutions. You might also see something like all real numbers. Just know that there are a very large amount of solutions that if we took and plugged it in for our variable here in this problem, we would have equals on the left and right. We'd have a very satisfied equation. So here we're going to go ahead and write down infinite solutions as our variable